Most people do questions randomly. Today they will do two-sum problem, tomorrow they will do sliding window, and the next day they will do prefix sum or Kadane, etc. And after a week or month, they will forget what they did. Why? Because they are solving the questions randomly. But arrays are not random. Today I'll tell you exactly 4 patterns following which 90% of questions you can solve in any of your interview or online assessment. So in this video I'll tell you how to identify those 4 patterns and how to stop brute forcing and start optimizing. But before going forward, you need to understand what is array actually. So array is the contiguous memory allocation for any element, and that element can be integer also, string also, and character also. And now when I will ask you to compute from this array, the method of computation will vary. And that different methods is nothing but patterns here. So let's learn what are those different methods to solve the problem. So first pointer is to pattern. Basically we will be using 2 such point or indexes to compute the answer. But wait, what is this 2 point actually I am indicating to? For this, let's take an example. You have 2, 3, 5 and 8 as an element in the array. And I have asked you, can you give me 2 such number whose sum is equal to 10? Yes. So if you don't know about 2 pointer pattern, what you will do? You will simply start your I loop from I is equal to 0. And basically you need 2 points. So for the second point, you will start your J loop from I plus 1. Correct? And now you will start comparing. Is 2 plus 3 is equal to 10? No. Then you will keep your I pointer here only and move your J pointer at 5 and you will ask, is 2 plus 5 is equal to 10? No. Again you will keep the I pointer here only and move your J pointer at 8 and now you will say yes, 2 plus 8 is equal to 10. So in this case you are running 2 for loops, one for I and one for J. So hence you can say the time complexity will be O of n square. Yes, you can. But this is the brute force approach. The 2-pointer approach says instead of running the for loops for 2 times, you keep a pointer at I is equal to 0 and another pointer at right index. But remember, you cannot apply this approach when the array is not sorted, or even if it is not sorted, the order does not matter. Why I said this? Suppose the array is not sorted and it says order does not matter, means you can sort it. So basically you can apply this 2-pointer approach only on the sorted array, whether it is given or you are doing it. So this approach says you will keep a pointer at left index and right index, and now you will start comparing it. Is 2 plus 8 is equal to 10? In this case it matches, so you will simply return true. But suppose your target was 8. So in this case, as your first pointer is at 2 and last pointer is at 8. So you will do summation and summation is 10. But wait, you need 8 and you have 10. So don't you think you should have added a lesser number so that you could have the summation as 8? Yes. So when you want to add the lesser number here, you actually move your right pointer towards left side. So hence your left pointer will be at 2 and right pointer will be at 5. And now the total summation is 7 and you want 8. But wait. Don't you think you have to add a bigger number so that you can reach to your target? Yes, you can. So in that case, you will move your left pointer from 0 index to 1 index. So now your pointers will be pointing to 3 and 5. And in this case, you will say ki yes, your target matches. And hence, instead of 2 for loops, you have used and solved this question in just 1 for loop. So time complexity will be O of n here. But suppose instead of 8, you had some target whose value cannot be found. So suppose you had 9 here. So in this case, 3 plus 5 is 8. And as the summation is 8 and you have to reach 9, means you have to add a bigger number to reach. So you will move your left pointer at right. And now at this point, both your left and right pointer will be pointing to the same index. And in this case, you cannot say you have 2 such numbers. So hence your while loop will break here. And this was about the 2-pointer approach, which decreases the time complexity from O of n square to around O of n. So following this pattern, you can solve problems like 2-sum problem, 3-sum problem, sort colors, move zeros, etc. And trust me, if you know this pattern, you can solve multiple questions because 2-pointer approach is being used in another patterns as well. Now, another very important pattern is sliding window. So similar to 2-pointer approach, in the sliding window, you will be asked to give the summation of continuous array. or you can say subarray. So remember, whenever you will be asked subarray, substring or maximum length of subarray, you can think of sliding window here. But wait, what is this window I'm talking about? Window is nothing but, you can say it is a part of array or a subarray basically. So suppose the question says for size k is equal to 3, can you give me the summation of all subarrays? So basically the first subarray will be 2, 4, 5 and its summation is 11. Next time the summation will be for 4, 5 and 7 and the summation is 16. And last time 5, 7 plus 6 and the summation is 18. So basically I have asked you the summation of all subarrays and at the end suppose I asked you to return the maximum sum. So in this case the maximum sum will be 18. So basically if you have to solve this with brute force approach, how you would do this? You will start your one pointer for I is equal to 0 and then you will keep moving till the size 3 and keep adding it in summation and you will store in some resultant array. But for the second window or second subarray, again you will move your I pointer at I is equal to 1 and now again you will move for 3 size and you will add all these values and put in the resultant array. Now for the third time, you will move your I at I is equal to 2 and again you will run for j 3 times and now you will do the summation and store it in the resultant array. So basically you are running your j loop for every I for k times. Here the k is equal to 3, but what if the k will be a very large number? In that case, the time complexity will be O of n into O of k. So basically if the k is large, so it will be near around O of n square. But what is this sliding window here? First window says 2, 4, 5 and second window says 4, 5, 7. So when we run the two for loops for I for kk times, we noticed that this 4 and this 5 is common in both. Then why we are running this whole for loop again and again? If you will see more clearly, the only difference was for the first array where 2, 4, 5 and in the second subarray of 4, 5, 7, if in the second subarray you will just put the 7 and you will remove 2. So you can say that first subarray will become the second subarray. It just says add the next number and remove the previous number. So here also you will keep two pointers. First pointer you will keep at I is equal to 0 and second pointer will be at k minus 1. And you will get the first subarray. For the next subarray, you will just add k plus 1 value in the summation and subtract this previous index value, which is called left pointer. So the simple concept of sliding window will help you to solve multiple questions wherever question asks subarray, substring or maximum length, minimum length, you can think of sliding window. Sliding window is also of two types, fixed sliding window and dynamic sliding window, where your left pointer and right pointer will be fixed. It is called fixed sliding window, and in dynamic, your left pointer will be at the same point and your right pointer will be keep on moving until some condition fails. And those things we will learn when we will start solving questions around this pattern. Now the next pattern is prefix sum, and we use this pattern whenever we need the continuous summation of subarrays. Remember, subarrays and not arrays. And why we cannot solve with two pointer and sliding window? Let's see. Suppose a question asks you, hey, can you give me the summation of all the subarrays from index 0 to index 2? Means I am asking for 0 index, first index and second index. Yes, you can. You will simply start with I is equal to 0, this left pointer, and you will keep moving till I is equal to 2 and you will add all the values and put in your answer. But suppose next time I'll ask you for index 2 to 3. So basically you will again start from I is equal to 2 and then I is equal to 3 and you will keep adding this. But instead of one time, if I'll ask you for n number of times, means this query will be like from 2 to 3, then from 0 to 5, then from 3 to 4, etc. So basically for every query, you are actually running around n number of times and there are n size queries, then basically for n times. So total O of n square time complexity, and your sliding window or two pointer fails. And that's where prefix sum comes into picture. It says ki do one thing, calculate the summation of continuous subarrays and store it in some resultant array. Means we will create a resultant array and we will save the continuous summation till that index. So this is I is equal to 0. So till here, what is the summation? Only 1. Okay, now next time this I will move to I is equal to 1, and resultant of I is equal to 1 will save the answer of summation of arrays till here. So can I say 1 plus 2 total 3? Yes. Next time it will save the summation from I is equal to 0 to 2 index, means 1 plus 2 plus 3. Yes. So can I fill this 6, now 10, now 15? Yes. And now for all the queries, my resultant array will give the answer. Let's see how. What you want? You want summation from 2 to 3, correct? And this is a 0 index, 1 index, 2 index, 3 index and 4 index. Okay. And you know the summation at third index have saved the answer from 0 to 3. And the summation till here, 1 index, would have saved the summation from 0 to 1. Yes. So basically, don't you think if you will subtract this and this, you will get the summation? I am saying 0 to 3. So it will have answers for 0 index, 1 index, 2 index and 3 index, correct? And now I am saying for 0 to 1. So 0 index and 1 index summation will be there. So basically I am subtracting it. So basically 0 and 1 I am removing from here. So what is that rest index value it has stored? So suppose this is left pointer and right pointer. So I am saying we will do resultant of right pointer minus resultant of left minus 1 pointer. And resultant of right pointer, basically 3. So I will go and resultant of 3 will be 10. So I will do 10 minus resultant of left. Left is 2. But 2 value I cannot exclude because 2 is having my answer. So I will subtract 1. Resultant of 1. So I will do 10 minus 3, so total 7. And hence one-time calculation of this prefix sum will help us to answer all the queries in just O of n time complexity. Although it will take O of n space-time complexity as well to store this prefix answer, but it is still okay because we are decreasing the time complexity here. And remember, problems like subarray sum equals k, continuous summation subarray or product of array except itself, which actually not prefix sum but it follows that prefix concept, are problems from this category or pattern which you can definitely solve after this. And now the last pattern is Kadane's algorithm. And remember, sliding window fails when negative number becomes a part of array. And that's where Kadane's algorithm helps us to resolve the answer. Let's see how. Suppose you have an array values called 2, minus 4, 5 and 6. And you will be asked to give the maximum summation of the subarray. Then in that case, with the sliding window, you will add this 2 number in the summation and your summation will become 2 and maximum will also be 2. Next time you will add minus 4 also. So your summation will become minus 2 but your maximum will still be 2. Next time you will add 5 also and this time your total summation will become 3 and now maximum will also be updated to 3. Next time when you will add 6 also, your summation will become 9 and your maximum will also be 9. With sliding window you got this in O of n time complexity. With the help of 2 for loops, so you can find the answer but not in O of n time complexity. And that's where Kadane's algorithm helps you. Kadane says when you are running your summation of subarray and once your summation becomes negative at any point of time, then do one thing. Don't keep that summation or don't bring that summation going forward. Why? Because see, till 0 and 1 your summation was minus 2. And if you will leave this minus 2, then going forward your final answer will be 5 plus 6 which is 11, which is for sure greater than 9. So that's what Kadane says, ki when your summation becomes negative, then you just need to update your summation to 0. And after this, that sliding window concept will help you here. So Kadane's is a modification of sliding window, you can say. But with this concept, when summation becomes negative, we will just initialize or reinitialize our summation with 0. Saying we are not taking this negative summation with us for future because that will reduce our final answer. And problems like maximum subarray sum, maximum average subarray, you can solve using this concept. So don't forget this point. Sliding window fails when negative number becomes a part and you follow this Kadane's algorithm there. So we have learned 4 patterns till here. First was two pointer. Two pointer was all about movement of pointers in the array. Second was sliding window. Sliding window we use whenever we have to talk about continuous subarray or substring. Third was prefix sum. Whenever we need continuous summation of subarrays or subarrays count, then we go for prefix sum. And fourth and last is Kadane's. When negative number becomes a part of subarray, we basically ignore the sliding window and we use this extra if case for this negative condition. So if you will remember all these pointers, trust me, whenever you will see the new question, you can recognize the pattern on your own. And if you want to solve questions around patterns, and I have curated a DSA pattern wise sheet for all of you so that you can practice questions after learning the patterns from here. And the link you can find out from the caption below. I hope this video was helpful. If it was, don't forget to mention below in the comment section. And also if you want videos on another topic, you can let me know. And one more request, if you found this video really helpful, then don't forget to share with your friends and do subscribe the channel for the future learning. And that's it for the video. We will meet in another video with some more interesting topic. Till then, keep learning, take care of yourself and your family.